Wait, hold on. Okay. G of x, kids. This is important, everybody. This is important. It says g of x. What do you think the most common mistake is when people substitute values into this function? What do you think the most common mistake is? It's a problem with the negative. Is the negative being squared? No. Let's say it again. The negative is not being squared. So on number 5, it asks, what is g of negative 2? What are you plugging in? You're plugging in negative 2 for x. So you're plugging in negative. So the negative is already there. It's the same one. But then it's going to be negative 2 squared plus 4 times negative 2 plus 1. What's negative 2 times negative 2? 4. And I don't have to use the bracket. No particular reason. So it's 4 plus, what does that become? Negative 8 plus 1. So what do you end up with? Negative 4 minus 8 plus 1. It's going to be negative what? 11. Correct. It is negative 11. You have to be very careful about the negative signs. Be very careful. The negative is not being squared. Essentially, wherever you see x, replace it with parentheses, the number you're plugging in. Parentheses. It is much more common for someone to make a mistake because they did not put in enough parentheses than if they put in too many parentheses. I very rarely see someone put in too many. Do I see people not put enough in all the time? Yeah. Katie?
Oh, wait, for these ones, like 12, 15, 18.
For 12, 15, and 18, okay.
And like 21.
Yeah.
I wasn't sure if I was supposed to like simplify them all.
Okay. So for number 12, there's nothing really to simplify because you're just plugging in k. But which one? Pick one do you want to do?
Well,
15?
Like 15.
Yeah, let's do 15. Sure. It's going to depend on what the question is asking. I understand, but did you go far enough is what you're asking. I think it's what you're asking. So it tells you f of x is equal to negative 3x plus 4. And it's asking you to find f of x plus 2. So what do you replace x with? X plus 2. So theoretically, if I did not ask you to simplify, you're done. If I did not ask you to simplify, you would be done. But can you simplify that?
Yeah, I did.
Yep, and it would be negative 3x plus minus 6 plus 4. Yep, plus 4. What's that going to be? Negative 3x. Yes, generally speaking, if it's only 2 lines, yes, I want you to simplify a little bit.
Okay, but for number 12, it was okay to just leave it as like negative k squared.
There's nothing else you can do to that.
Okay, and then for like.
Which one?
What was it?
Pick one. Yeah. So g of x, what was g of x? G of x was negative x squared plus 4x plus 1. So it's asking for g of e. What do you plug in for x?
Just e.
Yep. You leave it like that, correct. There's nothing you can do to that at this point. Actually, as a side note to this, e is actually a number. Does anybody know what e is called? It's called the natural number. You see it. You know how pi is a number, but it has a special name? E occurs in nature. It's 2.718. It's irrational. It keeps on going without repetition. You can't write it as a fraction. So theoretically, if you type that in your calculator, do you get a number? You actually do, because e, the letter e, is a number, just like pi. To do this out, you need to evaluate f of 4. Remember that f of x is negative 3x plus 4. So if we do f of 4, that means we plug in 4 for what? Negative 3 times 4 plus 4. What's negative 3 times 4? Plus 4 is? You can do it. 8, yeah, negative 8. So that right there is f of 4. That is f of 4. So what about g of 4? It's going to be g of x. What is g of x? Negative x squared plus 4x plus 1. So g of 4 is going to be negative 4 squared plus 4 times 4 plus 1. What's negative times 4 squared? Negative 16 plus 1. What's that equal to? 1. And where does that go? Right there. So what do you end up with? Negative 8 minus 1. What's that equal to? Negative 9. And you are done. What is this in? What form is this? Slope-intercept. And if you're going to graph something in slope-intercept, what point should you start at? Yeah, because it gives you it. Where is the y-intercept? 0, 5. I like you saying 0, 5. That's fine. But right there, that's the point 0, 5. And what's the slope? What's the slope? Negative 2 over 1, so that means go down 2 and over. Down 2 and over 1, down 2 and over 1. So what can you do with all those points? Connect them, that's right. There's a draw tool here I like to use, if I can remember to use it. Draw, let's use this one. That's not bad. Not the best, I didn't go through all those points there. But there's your line. Well, I'll do a better one. You can see it here. There it is. Negative 2x plus 5. If it's in slope-intercept, start with the intercept and then plot a second point. The question is, what's the domain and what's the range? Who thinks they know what the domain is on this? Over to the right? Was that you, Calvin?
Yeah.
What is it? What's another way to say that? Yes, this is correct. If you wrote that, that would be fine. What's another way to say that? What is that? Yeah, you could say it like this. You could say it is, yeah, this is all what?
Can't you say x is like no real?
Yeah, you can just say the domain is all real numbers. It's a 2 bars R. This means all real numbers. You can say all real numbers. That's fine. ARN. What about the range of this one? What's the range? Correct. It is also all real numbers. How far up does it go? How far down does it go? Oh, it goes all the way up and all the way down. Does it skip over anything? Does it skip over anything horizontally? It covers the entire x-axis and it covers the entire y-axis. All lines that aren't straight up or down or horizontal are going to have domain and range of all real numbers, because all lines that aren't straight up and down are going to go out and up infinitely. It's asking you to find x when if f of x is equal to 4. Is 4 a y value or an x value? It's a y value. This question is asking, what is x equal to when y is 4? So how do you figure that out? You go up to, well, you don't know the equation, you can just use the graph. Here's y equals 4. Do you agree with that? No, it just gives you the line. It says y equals f of x. Just take a look at the picture. Kelly, take a look at the picture. If you're at y equals 4, let's go over here. So once you're at y equals 4, go over to the function, and then you go down to the x value. What x value is this? 3. So x is 3. The next one asks you, it tells you f of x is equal to negative 2. So you go down to negative 2. What x value are you at? 0. X equals 0. And then the last one, I'll change colors here. The last one says, for 36, f of x equals 0. So that's where y is equal to 0. Where is y equal to 0? Right there. So no, it's right there. That's where x is equal. That's where y is equal to 0. So what's the x value? 1. So that all those are asking you is if they give you the y value, what is the x value? That's it. Others, any other negative 1 is? Here's negative 1 right there. 1, 1, 2, 3, 4. It looks like this right there is negative 4. Go forwards or backwards. When is it not? Well, here's an example of when it's not. So let's say I gave you this. Here's x and y. Let's say I gave you this right here. Let's do one like this. Looks kind of crazy, but I'll give you a few values. Let's say that's, let's say it's negative 2 right there. Let's say that one's 1, and let's say that one's 2. What's the domain of this function? What part of the x-axis does this cover? What part? All of it. It gets infinitely wide. So it is all real numbers. What, though, is the range of this thing?
Negative 2.
Negative what? How far up does it go? There it goes. Keeps going up. There it is. What's the lowest value? Negative 2. How high does it go? Keeps going. So does it ever stop? No. Does it matter that it, for the purposes of range, does it matter that it doubles back on itself? No. It's just asking you, what is the set of output values? The set of output values is everything greater than or equal to negative 2. What about holes in the domain? What are the 2 things you can't do? What are the 2 operations you don't like? 2 things. Divide by 0, and what's the second one? Square root of a negative number. So for example, let's say I said g of x was equal to 1 over x. Come on in. If g of x was 1 over x, what's the only number I can't plug in? Can't plug in 0. So what can you plug in? Correct. So you could do it two ways. You could do it in interval notation. You could say it like this. Sorry. Ooh, I shouldn't put hard bracket, right? You could say this, union, it's everything besides. And one thing that mathematicians like to do is they like to write words as symbols. You might see this, x such that x doesn't equal what? 0. Or you could write out the sentence, all real numbers except for 0. That would be totally acceptable. Totally acceptable to say that. But mathematicians like to write things. Did I explain what that bar means? Have you seen that before?
Absolutely.
Yeah, if there were two of them, it would be. Also, a problem with math is we tend to use the same symbol over and over again for different things. Like, what do we stop using as multiplication? What do we not use anymore? Never use an x for multiplication anymore, right? That's not a good. And then what do we sometimes use instead of the x? Parentheses or a dot, right? Anybody know what a problem is when using dots? It could be decimals. If you're not very neat, it might be hard to understand. But then if you take more math, guess what the dot can mean? Lots of things. The dot can mean many things. So you stop using dots. Mathematicians like to think we're clever. We're not sometimes. We're really not. We're really not. This means such that. Do you want to see a really confusing sentence? Anybody want to read that out loud? A upside down, A, X, E. Yes, I'm really excited. A such that A greater than 0. It's gibberish in math, but what it says is there exists an A. For all A, there exists a unique. For all X, there exists a unique A such that A is greater than 0. How many different words do you think exist in all of math compared to, say, Shakespeare? Yeah, there's like 12 words, right? When I was in Hungary studying math, we had to learn Hungarian. Anybody know anything about Hungarian? It's terrible. Hungarian is a terrible language because it's impossible and not related to anything. Our math test would be in Hungarian. Why was that acceptable?
So do you speak it fluently?
Can you answer the question I just asked? Very well stated. It's also in Hungarian because there were only like 16 words we needed to know in order to do our math tests. I cannot speak fluent Hungarian. That means I only speak a little Hungarian and I'm American. Ida a penzet is give me all your money. We wanted to know that phrase so we knew if we were getting robbed. And we actually heard it a couple times. Okay, moving on. Other questions from the homework. What do you got, Nate? Aren't straight up or down. What's the domain of that function? All real numbers. What's the range of that function? Exactly. Oh, we're supposed to solve for values. I'm sorry, f of 2. So if we're trying to find f of 2, are we trying to find an x value or a y value? It gave us the x value. We're trying to find the... So where do we go? Where do we go on this graph? And then we go down. And it looks like if you go to 2, it's at negative... It looks like it's at negative 3. So it's actually negative 3. And then the other one is f of negative 1. Are they looking for an x value or a y value? So you go to where x is negative 1. And then you go up. And on this one I'm looking at, it looks like it's at 2. It goes to 2. Exactly. Particular? Anybody remember?
Yeah, upside down T.
Yeah, upside down T. Nice. That is in what form? Are there other forms we could transmute it into? There are. There are 2 of them. What are the other 2 forms we could go into? We could go into standard form. And I know you really want to go into slope intercept to feel good about yourself. I know. We're not going to, though. If I wanted to go to standard form, someone tell me one word of what I should do first. Y minus 5 is equal to 5 over 2x minus 5 over 2 times negative, well, times 2. I put the negative on the outside, yep. Times 2. What would you then need to move? Or what would you want to clean up next?
Or combine like terms and then subtract 5 over 2.
We could subtract 5 over 2x. We could do that. So y minus 5 over 2x. And this, what, can I cancel that? Is that okay? Can I do that? I think I can.
Yeah.
Oh, look, I have -5 and -5 on both sides. What happens? Do they go away? To get rid of this 5, I have to add 5. What's -5 plus 5? So what am I left with on the right? Did I already move the 5 over 2x? Okay, hold on a sec, kids. I did too many things at once.
Yeah.
Hold on. Let's pause. Times 2. Let's do this step by step. Can this be simplified right here?
Yes.
What does that simplify to? Just 5. So we have y minus 5 is equal to 5 over 2x minus 5. Am I still okay?
Yep.
If I add 5 to both sides, what happens?
0.
What happens?
Cancel out your 0.
So you have y equals. Is that in standard form? What is standard form?
X plus
X and
y.
Y.
So is that in standard form? No.
Subtract
X and y have to be on the same side. So what do we have to get rid of?
X or something.
We'll subtract the 5 over 2x minus 5 over 2x plus y is equal to 0. How do we feel about this? Do we feel okay about this? Now, there's one last side note. You can start packing up because it is a little 2 minutes past. One last side note. Some books, they don't like fractions in front of the x value or the y value. They don't like fractions in that at all. I don't care right now, as long as you have it in ax plus by. Where do you find your homework, kids? See you tomorrow for your test.